Hello, in this video we're going to talk about systems of equations. I'm going to start it off with a simple problem. Imagine that you are deciding to ship a package and UPS charges $2 per pound to deliver the package plus a service fee of $6, whereas FedEx charges $3 per pound but only a $4 service fee. What company should you use? So what we're going to do is come up with a system of equations. And a system just means more than one equation. Okay, so for UPS, the cost of sending this package, C, is going to equal $2 per package, so that's 2p, or sorry, per pound, that's 2p, plus $6 on top of that. Okay, and now for FedEx, the cost is going to be $3 per pound, so 3 times the amount of pounds, plus a $4 service fee. And so what we can do is we can graph these on a coordinate grid. Now notice I'm only using the positive quadrant, where these would be the positive numbers here and the positive numbers here, because we're not going to be dealing with any negative weights or negative costs. So oftentimes real-world situations are handled in the positive quadrant, which is the first quadrant, but not always. So let's start with this, the red one here. So we know the intercept is 6, so 1, 2, 3, 4, 5, 6. So we'll say each grid line is worth 1. I want that in red actually. And then the slope is 2, so 2p, up 2 over 1, up 2 over 1, and so on. So our red line is going to be, we're going to connect these. For the green one, I'll just kind of do that by hand here. Get the idea. FedEx will be the green one. So that's the cost is 3p plus 4. So the y-intercept is 4. And then we have 3. So 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, and so on, all the way up to here. So when I graph these, what you'll see is that they intersect right at this point here. I'll do it in blue. And so that means something. And so in this particular case, it means the weight at which using either company would charge the same amount. Okay, and that so at 2 pounds, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Each company is going to charge you $10. Because for FedEx, 2 times 3 is 6, plus 4 is 10, so the cost is 10. And then for UPS, 2 times 2 is 4, but plus 6 is going to equal 10. And so the answer to the question of what company should you use is going to depend. If your package is less than 2 pounds, you'll want to use FedEx because it's going to be cheaper. However, if your package is more than 2 pounds, you're going to want to use UPS because the price will be cheaper. So a system of equations is going to help us find a point of intersection, which will help us answer any questions we need to know. So we're going to try out a couple examples. Alright, so here's another example. I have two equations. Remember, that's called a system of equations. And I'm looking for the point of intersection because at that point x and y will be the same for both equations, and that is the solution to the system. As we know, because I'm going to graph it right now, the solution to just one equation is a whole line because there's an infinite amount of solutions. 4 over 1, 1, 2, 3, 4 over 1, and so on. So I can make this line go something like this. Right there. Something like that. So again, the solution to this green equation is this whole green line. And the solution to the blue equation is going to be the whole blue line, which I'm going to make right now. 1, 2, 3, 1, 2, 3, 2, 3, and so on. So it looks something like this. However, at the point of intersection, which I'm going to put in red here, and I'll put the coordinates 1, 2, x and y are the same for both equations, so that would be the solution to the system. And we can check that too by plugging in 1, right? 4 times 1 minus 2 is 2. And negative 3 times 1 plus 5 is also 2. So you can see that this coordinate works just as well for both equations. And that, in fact, is the only point in this whole coordinate grid that will work for both equations. Okay. Let's go into one more example here. Oops, I forgot to pull a grid out. There we go. Oops. Okay. So for the green one, y equals 2x plus 1, y-intercept at 1, sloping up 2 over 1, or down to left 1, sorry. Down to left or up 2 and right. Alright, now I connect these, put a little arrow showing they go on forever and ever, and the blue one, starting at negative 2 as an intercept, going up 2 over 1, up 2 over 1, up to right 1, up to right 1, up to right 1, and then down to left 1, down to left 1, and so on. So, as I'm graphing this, you can see that these lines never touch. Now, first thing you have to ask yourself is, are they never going to touch, or are they just not touching on the portion of the graph that we see? Because remember, these go on forever and ever. Well, it looks like to me that they are parallel, and so even though they go on forever and ever, they will not touch. So when that happens, that your two lines do not intersect, we call that a no solution problem. No solution. There's no point that works for both equations. Okay. Now, if it's just that you need to extend your line out farther to see the point of intersection, then you have to do that. All right. Thanks for watching. Tomorrow in class, we'll do some examples of graphing systems of equations.